Alright, Module 2.6, Shopping for Cats and Dogs. Develop understanding task. So we are just trying to get some ideas going about what's happening here. So Clarita and Carlos are trying to figure out which deals on dog and cat food are the best. They looked up some online coupons but are struggling to figure out the cost of each type. Can you figure out which would be the cheapest for them to purchase? Be prepared to explain your results. So taking a look at question 1 and 2 and 3 and 4, because I guess question 2 and 4 are just how you did 1 and 3. You're using these two coupons to figure out the cost per bag of cat food and dog food, right? Just how much each one of those costs to decide which is cheaper, okay, between those two. Alright, so the first one here probably would be pretty easy to figure out the cat food, okay? Say we've got 2 bags of cat food for $6, right? So if we divide that by 2, if we cut it in half, each bag of cat food would be worth $3. Simple enough on that one, right? Now, once you knew that, you could use that to help you with the other one. You could say, well, here we have 2 bags of cat food. So that's kind of like the $6, right? So if I take the $15 and subtract the 6 from it, what is left over is going to be worth dog food. So $9 would be for the 2 bags of dog food, and we cut that in half, and you get $4.50. Right? So we kind of use this concept of how much the cat food is and then substitute that price into our other coupon and use that to figure out how much the dog food is. Alright, so number 3, kind of we go with the same concept now. So look for similarity in 2 coupons. So you should probably try this one on your own first. Alright, so let's see if you did something like this. If we look at this, we see we've got 2 bags of cat food, 1 bag of dog food, right? Similar to what we have there. And we know that's worth $10. So that amount right here is going to be worth the $10. So we can substitute that $10 in for that amount of dog and cat food, which then leaves us with $10 plus this would be equal to 18. Well, then we just subtract the $10, right? To get the 2 bags of dog food would be equal to $8. Then we can divide that by 2, and we come up with a bag of dog food is $4. Once we know that, we can go back to our original and say if that's $4, subtract it from 10, we get $6. So once again, 2 bags of cat food equals $6, so the cat food is actually the same amount of money as it was at Walmart. But the difference is in the dog food, right? So Costco would be a better deal than Walmart. So once again, kind of using that concept of taking a piece, substituting what we know for something we don't know to figure out something else. Okay, now if we kind of take a look at it, but let's try to form it more of an equation, because all of these we could have formed into an equation. Okay, so kind of have a similar idea going on here. So how would we figure this one out? Take a look at it, see if you can think through this one. This one's probably a little bit more difficult. Okay, so you may want to think, well, I can take this and apply it to that, but it doesn't necessarily work because we still have some pieces left over, right? So probably the easiest thing we could do, well, maybe not the easiest, but one that might work, is thinking through, say, well, we've got 3 bags of cat food, 1 bag of dog food. Well, could I set it up so I had 1 bag of dog food was equal to something? Well, we know it's equal to $14, and if we knew how much each bag of cat food was, we'd just subtract that price from 14, right? So we could subtract the cat food, right? And now we know that 1 bag of dog food is equal to $14 minus 3 bags of cat food. Now if we take that other equation and say for each of these bags of dog food, we've got this situation going on. So then we'd have, let's see, we'd have 2 bags of cat food, right? Plus 3 bags of dog food. But we're saying that that dog food is really equal to 14 minus 3 bags of cat food. 3 times, right? Because there's 3 bags of dog food. Now, that doesn't look too easy, does it? But the benefit of doing this, and that was equal to $21, the benefit of doing this, and this is just because it had 3 bags of dog food, a little bit more difficult. The benefit, though, is that now all we're dealing with is cat food. Okay? Which means we can then figure out what's going on here. So I've got 2 bags of cat food, and then we're subtracting 9, right? So those 2, because they're positive, and 2 of these negative ones, we could erase. Okay? So we'd have 1, 2, 3, 4, 5, 6, 7, but they're minus. So we'd have minus 7 bags of cat food, right? And I'll kind of simplify it that way. Plus 14, 14, and 14 is 42 equals 21. Because we're making an equation, we can then solve like this and say that the bag of cat food is $3 again. Okay, now if we know how much a bag of cat food is, we can easily figure out what the bag of dog food is, right? So this is worth $3, $3, and $3. So add those together, that's $9, so 14 minus 9 would give us 5. So the dog food here would be $5. Alright, so that one was kind of a little more complex, wasn't it, to have to deal with? Okay, well, this process here, we've kind of introduced through all of these, we're still dealing with a system of equations. Because we have 2 equations here, right, we could call this 2x plus 2y equals 15. We could call this 2x equals 6. Okay, 2 equations. 2 equations here. 2x plus 3y, if x is cat food and y is dog food, equals 18. 2x plus y equals 10. So 2 or more equations, we've got that system of equations, and we were figuring out at what point were they the same. Same with this. Now this one, we can take that and make it even more equation-y. And so with a system of equations, we've already learned that with systems you can graph them. And when we graph them, we look for where they intersect. And that's our answer. Sometimes we know that they're parallel and there is no answer. Sometimes they're the same line and they always intersect. But we're looking mainly for that intersection point. Well, this is another way called substitution that we can use to help us figure it out. Because graphing isn't always the best way to do it. Okay, this substitution, the idea is like this. Let's get one of our variables by itself in one equation. Okay. It's exactly what we did up here with the dog food. The dog food was like the y. So I'd subtract the 3 and I get y equals 14 minus 3x. Okay, we could have simplified this and went 3 times 14 minus the 3 bags of cat food. Okay, now I know that y is equal to this. If I'm looking for where they intersect, I know that this y will be the same as this y. So what I can do is I can take this equation and I can substitute for the y what y is equal to in the other one. That whole thing. Just like I did back here. We substituted 3 times for all 3 bags of dog food. And then we can simplify. 2x plus 3 times 14 is 42. 3 times negative 3x is negative 9x equals 21. See those same numbers? 2x, 1, 2, 3 sets of 3, negative 9x. 3 sets of 14, 42. 2x and negative 9x combine to make negative 7x plus 42 equals 21. Subtract 42 because now we're solving for x. Equals negative 21 divided by negative 7. And we had x equaled positive 3. Okay, because we substitute in an x term for a y term, more than an x term, but it has the x in it, and we created it so we just have x's, that's why we're able to simplify it clear down to one answer. So the x value is 3. If I were to graph these, that's where they would intersect at the x value of 3. Then I can take this equation and say, well, now we know what x is. So now I once again substitute in that number for x, 3. 3 times 3 is 9. 14 minus 9 gives us 5. So the y value is 5. So if I graph those, that's where those two lines would intersect at 3, 5. That's the answer in our story problem, stood for cat and dog food. So there's a basic example of substitution and kind of those problems that dealt with it.